Hello learners, welcome to session 2 of unit 4 in the course Introduction to Abstract Algebra. In the previous session, we look at rational and irrational numbers. In this particular session 2, we are looking at real numbers. I am Munkaila Dasmani, your course instructor. Session objectives. By the end of this session, you should be able to state the properties of real numbers. You should be able to state the relationship between real numbers and other numbers. State the relationship between real numbers and real functions. Explain why the set of real numbers forms a third. Express the same real number in different ways. Real numbers definition. Real numbers. Real numbers contains all numbers of the form P on Q. Where P and Q are integers, Q is not equal to 0, as well as both terminating and non-terminating decimals. So in other words, real numbers are made up of rational and irrational numbers. So you can see these examples. Some are rational numbers and some are irrational numbers. That is, the 1 on 2 is a rational number, minus 5 on 7 rational here. 3 on 5 rational, but square root of 3 is irrational. You can also see 2 plus square root of 5 irrational. We have the pi here. We also have the exponential logarithm, the e. Okay, let's look at the diagrammatic representation of real numbers. So real numbers being the mother, and then giving birth to irrational numbers and rational numbers. The rational numbers too has given birth to integers as well as fractions, decimal or percentages. Then the integers also combines whole numbers and then negative integers. And then also whole numbers is having 0 and then natural numbers. And within natural numbers, don't forget about counting numbers, a whole lot of them. So, and that is the structure of the real number system. Real function. A real function from the set of real numbers or a subset of real numbers. That's every real number x in the domain. A corresponding real number f of x is defined. So we will look at example to explain. So example of the real function. Determine which of the following mappings f from real number to real numbers are 1 to 1 and what are onto. So this, we've done this already, so you go through this proof or this example, so simple, and you can see clearly that f of x is 1 to 1 as well as onto. For I is both 1 to 1 and onto, and also I is both 1 to 1 and onto. And I can see I is actually not 1 to 1 because x1 square equals x1 square. Get x1 we call square root of that, x plus or minus square root of x2 square, which is not actually 1 to 1 based on the definition, and it also is so not also onto. So it's so simple. Go through the solution, and it is also in your course material. I've already done this. Okay. Real numbers as a group. So a group is an algebraic system, consists of a set with a binary operation which satisfies certain properties. Oh, this is very important, and we are going to discuss a group. So domain, a whole lot, so integral domain, and then the rest in section 6 or in unit 6 rather. So we leave this group stuffs and then we capture them in unit 6.